conversation on semiconductors always leads to the same place. This is Taiwan, home to the Taiwan Semiconductor Manufacturing Company and a choke point that defines the entire semiconductor industry. Or does it? Taiwan is a useful story, but it's also an incomplete one. Behind the world's semiconductors lies a global network, occupied by a small group of powerful companies, each holding a position that no other can fill. Some mine the materials, some refine the materials, some make the machines that make the chips, and others make the chips themselves. The effectiveness of these companies defines if your car gets built, if military hardware reaches the front line, or if your data center comes online. But, as with every supply chain, there are risks, way beyond the seas of Taiwan. The Taiwan Complex is a story. Let's see how a single geography disguises the problem of structural supply chain risk. As people, we look for narratives and we look to simplify because it's a way in that we turn things that we don't understand into things that we do understand. And semiconductors is an example of how we do this on an industrial scale, and that we take an enormously complex issue and we condense it into a single risk in a single geography. So the risk of a blockade in the Taiwan Strait. And this is what the Taiwan Complex is. It is this oversimplification, this over focus on a single geography, on a single type of risk, when actually the risk is much broader. The risk is everywhere. It is a complex global supply chain. It's across multiple continents. And it is, as the pre-wave data shows, somewhere where the choke points are everywhere. Each stage in the supply chain has its own way of breaking. What the data shows is actually how true that is, whether this is in America, in the raw material mines where we look for high purity quartz, to the finishing steps in Taiwan, or the places in between where we're making the lithography tools, within Europe, where there are, in some cases, 90 to 100% dependencies on single suppliers. The semiconductor industry is a system built on extreme specialization and extreme concentration.
The semiconductor industry is highly concentrated. We looked in our report at 21 companies, which are focal companies for processes done in the semiconductor industry and in the production steps here. The important part is that none of these companies, of these 21 companies we looked into, are replaceable in any broader meaning. So everyone holds a bottleneck or a high concentration risk here. When you think of semiconductors, your mind obviously goes directly towards Taiwan, but that's not the only geographic exposure you face when you look at the semiconductor industry. The 21 focal companies here are geographically located in Europe, they are in the United States, but they're also in Japan and South Korea. So there is much more to the story than only Taiwan.
Of course, it's not just a supply chain. Semiconductors matter, and for that reason, geopolitics matter too.
Semiconductor value chain is actually quite interesting because it's a political power game. You can see the dependencies from Taiwan and China clearly, but also we can start in the beginning of the value chain with the design and the IP that heavily sits in the US. Then you have for sure the fab production and the packaging, very known, tied to Asian countries. We also have the European expertise as a power game with expertise for equipment. And a lot of people are overseeing the most upstream step, the raw materials, and there you can find some very interesting bottlenecks.
Spruce Pine, North Carolina. Its claim to fame? Supplies the bunker sand for the Masters Championship to the Augusta National Golf Club. However, the 57 million viewers of the 2026 event were reliant on Spruce Pine for an entirely different reason.
So there is this small town of Spruce Pine in North Carolina. It has about 2,000 villagers living there, and nobody would expect what a political position this small town has. So Spruce Pine is the one and only to solve you with pure quartz worldwide. So 95% of all pure quartz production is coming from there, and served by two companies, Sibelco from Belgium and the Quartz Company from Norway. So again, Europe coming into the play.
High purity quartz is what the world's silicon wafers are grown in. Without it, no chip can be produced. However, its supply is controlled by just two companies, and the geography itself is the risk.
The geopolitical power plays are not the only thing. If you create a lot of bottlenecks, you're also exposed to extreme weather events, for example. So if we come back to Spruce Pines, It was heavily disrupted 2024 during Hurricane Helene. What you would not expect, we just said Spruce Pines is a small mountain village, not exactly exposure to hurricanes expected, but Helene actually forced Sibelco and the quartz company to shut down their productions for several weeks. And often it's really a ripple effect. So it's not just the production itself, but also therefore the transportation and the infrastructure points around the production sites.
Every step, I would say, along the semiconductor supply chain faces its own set of risks. So we have, in the mining industry, we have less technological risks, but we are exposed to natural disasters like hurricanes, like the hurricane we saw 2 years ago in Spruce Pine, for example. When we go further, we have high technological risks. When we look at ASML, they're dependent on high-tech lasers and glass manufacturing, also from very specialized companies here. So that's a different set of risks. Their intellectual property and know-how protection is highly important. When we look into the chemical part of this supply chain, we have to think of operational risks like fires, like explosions in plants, because that's nature of the business of handling these chemicals. And then we go all the way to geopolitical risks when we think of Taiwan. And of course, along the whole chain, we see natural disaster risks, especially in the Asian part of the world, where we're highly exposed to hurricanes and tropical storms and things like that.
At the very top of the equipment pyramid, one single supplier. Dutch by headquarters, global by dependence.
ASML is a famous producer from the Netherlands for ultraviolet lithography machines. They also do deep ultraviolet lithography machines, but they have a complete monopoly in producing these machines with the knowledge from Europe and a very deep dependent network in expertise here. So in other words, TSMC would not produce any advanced chips without ASML.
Analyzing the Taiwan complex starts with visibility, and that means data.
What we're basically doing is we scrape the web, so mostly news magazines, but also industry-specific magazines for risk events. We utilize natural language processing in the first step to just identify what could be interesting relating to supply chain risk and narrow it more and more down with advanced AI methodologies, including LLMs, to identify the most relevant ones. We match them through our alerting pipelines to a little over 100 different event types, covering sustainability topics such as child labor, modern slavery, as well as resilience-related issues, for example, operational disruptions caused by explosions, fires, but also financial, for example, insolvency, liquidity issues, obviously shortages, and many more.
But the data is one half. The other half is knowing where in your own supply chain it actually matters.
To identify risks in the deeper supply chain, the key part is identifying those companies in the deeper supply chain first. Not only identifying all the companies in the deeper supply chain, but the relevant companies in the deeper supply chain. And we have a process we call mapping, which in the first step utilizes trade information, so bill of ladings, to identify trade relationships between companies. They also come with HS codes, which are basically product codes, so we can filter it for relevance for our customers, identify the companies underneath, set them up as targets, and then apply a regular media monitoring. It both works top-down as it works bottom-up. So while our customers usually give us their supplier and we identify the deeper supply chain, it also works the other way around. You could take a company like TSMC, map basically their customer upwards, and identify relevant companies in that respective segment from there.
If your company relies on semiconductors, your resilience begins upstream. The Taiwan Complex highlights the paradox of supply chain preparedness. The things we expect to go wrong are rarely the source of the greatest disruption. While planning for expected disruptions is crucial, having a structure in place to respond to unforeseen events is the gold standard of resilience.
If you want to be very sure that your semiconductor supply chain is not failing, you need to start mapping your deepest supply chain, especially with structured supply chains that are so heavily interdependent and clustered. You need to understand every single step. This is also where Prewave can help to map your supply chain, but also update it regularly. So these are not static systems that are not moving at all, but also risk probabilities are changing, players are changing, options are changing, and your competitive advantage will come from understanding these changes and having deep visibility.
In a mining town in the Appalachians, in a clean room outside Eindhoven, in a chemical plant in Japan, in a packaging hub in Penang, each step of the semiconductor supply chain carries risks with few alternatives. The question for any business reliant on chips is no longer what happens if Taiwan is cut off. In fact, it never was. It's if you really know where the structural dependencies lie. Talk to Prewave. We'll help you find them.